Well, hi, and welcome to my shop, and thank you for joining me here on September 7th. Why is this radio here? Because I forgot I wasn't quite done with this radio. This is the one I've been working on the last week or so, and I got all excited yesterday, put it back in its cabinet. Cabinet still needs work and whatnot. Got that other radio out. Hey, I'm going to fix up that other radio now. But then I realized I forgot something with this guy. I forgot to change the great big capacitor that's in there, the chassis capacitor. So I'm going to take it back out of the cabinet, and we're going to change that big capacitor and see what happens. Now, in other cases, I might just say, "Wow, I forgot about it. Who cares?" But this particular capacitor has an impact on the safe operation of this radio, or safer operation of this radio. If the big capacitor were to develop a short in it, then this radio would become potentially a dangerous radio. Things like these screws that I'm screwing. Now these are going into wood, so these are okay. These screws don't matter. But there are some screws underneath. The idea is somebody would have the radio plugged in, they'd be in their bare feet, standing on their basement floor. They pick the radio up like this, and to move it, and they touch the screw underneath here, and with that capacitor shorted, it could get pretty exciting. Not the kind of excitement most people are looking for. Be an electrifying experience, yes. So I just felt I couldn't just leave that in there. Plus I'm a little bit curious about that big capacitor. What condition is it in? I think bigger capacitor, bigger leak. So if it's leaky, and something else I would be interesting to judge is, well, how leaky can it be before you're exposed to a real shock hazard? They're going to get an electrocution from it. So I think that's the easiest thing to figure out. Generally 2 or 3 milliamps as I understand it, but don't quote me on any of this. 2 or 3 milliamps is enough to get you into trouble, maybe stop your heart or something like that. How do you get 2 or 3 milliamps? Well, you need a significant voltage, 100 volts or perhaps more. All depends, of course. If you're like me, I have very moist skin. I'll tell you a story. I was watching an electrician work. I was in college, and he was in the apartment building I was working in. I was a maintenance guy in an apartment building, small maintenance guy. And this electrician walks over to a outlet. The outlet is gone. He's in the process of working on it. The wires are hanging out. I just walked into the room, and I watched him walk over and with both hands grab the white and the black wire like this and go, "No, I don't think this is live." And all I know is that if I went over and did that, I don't think I'd be alive. I couldn't believe it. So I ran over to the guy, basically. I said, "What are you doing? What are you doing?" And he goes, "Oh, don't worry, my hands are so dry." And he showed me his hands, and they were dry. My hands are so dry, I don't even feel it when I touch these wires. Holy smokes. Holy smokes. Not a recommended procedure. I do not recommend that. We have voltmeters in this world. We don't have to be the voltmeter. Okay. Now that radio's got more asbestos in it than any other radio I've seen. Okay, here we are. I got it out. And that's the guy right there. He's still there. I thought maybe he had taken off in the meantime. Oh, he's still there. Okay, so why don't we take a peek at the schematic, even though I think it's pretty obvious what this guy's up to, but let's have a look at the schematic. Okay, I doubt I can explain all this thoroughly, and I'm likely to make some mistakes in what I say. So if you like filling in the gaps by making comments on my video, here's a big opportunity coming. So this is the capacitor that I have left in the radio to this point. Great big capacitor, 0.2 microfarads. And what is it between? It's between the B minus line, which is right here, and this, which represents the chassis. I wish the drafter had made it just a little heavier yet than how he set it. So it's quite distinct from the wires in the radio. But that's what that is. That's the chassis. Now if we look around at what is connected to the chassis, we see it's the shields on the outside of all these metal tubes. Okay, that's just kind of more chassis, really, in a way. We follow it along here. Things start getting a little interesting. So here's a connection. It goes through the primary side of this winding capacitor and out, and that's the wire that's hanging out the back of the radio, the wire I was using when not using the loop antenna. That's connected to the chassis. It's not connected to anything else, so this is kind of like an isolated, again, extension of the chassis, or the same potential as the chassis, I guess you could put it. Or the antenna, I'd put it this way, the antenna is finding its ground on the chassis, or is it really finding its ground through here? Or didn't I find another capacitor that also could be resulting in grounding? Didn't I? Didn't I? Some other video? Yeah, I don't know. Here's another connection to the chassis, and this is coming here to the tuning capacitor. And this really represents the frame of the tuning capacitor. It's bolted to the chassis. This is a bolted connection here. Of course, the tuning capacitor frame is also depicted down here. Same thing. So we have the frame, but the frame only, well, it connects through this. Now we get to the mysterious 0.05 capacitor here. Tried to figure out what this is for exactly, and I couldn't. It comes up here to B minus. I couldn't sort this out. But this is the local oscillator here. Local oscillators built around some of the grids that are inside the tube, not using the plate circuit. And of course the feedback is this transformer feeding back energy from the amplified energy coming out of the tube through these two grids. Yeah, and one grid is used as a plate, and some of that energy goes into here, gets through this little tiny capacitor, comes up and gets onto grid number 0, or the first grid in the tube here, and that's the oscillating feedback type arrangement here, and then the tuning capacitors down here. And again, the capacitor is connected by default. It's bolted. It's not like this on every radio. Different radios do this differently, and this is probably why my knowledge is foggy here, because every time I look at a radio, the clever engineers have done something a little bit different with their radio. Okay, is there anything else? There's nothing else connected to the chassis. Just the interesting stuff is right in here. Can this capacitor affect the operation of the radio? The ability for it to receive? Well, if it is the path to B minus for signals coming from the antenna, maybe. I suppose. I mean, like, a good deal of this radio is kind of not sensitive to the chassis. And again, I'm saying stuff, maybe it's interpretable what I'm saying. So what I've got really in my head may not be coming out of my mouth without some conversion occurring. So beware. Okay, so what would happen if I changed it? What would happen if this wasn't there? That's a better question. Okay, so if this wasn't there, there'd be no connection. This is a big capacitor. B minus would not be connected to the chassis, and all these things would lose their connections to B minus. Well, you know what we're going to do? We're going to cut this capacitor out and see what happens. We'll do it in stages, and I'll try to remember this time to actually do it. So I'll operate the radio, and I'll just nip this capacitor. Now, something dangerous happen? I don't think so. Nothing more dangerous than what I'm usually doing in my shop. And a 0.2. We'll stick another 0.2 in there in the end. We'll take this out and test it, of course, and find out the whole story. What about the amount of leakage through there? Could I measure that at this point? I have actually my Sencor power supply there has a feature, but I'm not familiar with it. How I would use it in this situation exactly. But I think it's built exactly for this. So let's try that. Let's try that first. We'll try the leak reading on the meter. Then we'll try cutting this capacitor free, see what happens with the radio operating. Then we'll test the capacitor, stick another one in, and see what we got. Okay, that's the plan. Okay, sometimes I mention about just having these radios in your shop, but there's a danger you're going to damage them in some unexpected way. Like, for instance, plunging your thumb through the speaker, like I just did a couple of minutes ago or a minute ago. I actually split the speaker right here. Okay, another thing that needs to be fixed. So here's the probe. The probe is plugged into this guy. I'm going to push this button here. It says high side. Well, this meter's actually forced down below zero. How could that happen? Low side. I'm not touching anything. Oh, now it's normal. I think maybe it got stuck down there. I don't know what happened just there. I don't know. On this probe, it has this button here. It says push to read true leakage current. But this doesn't feel like much of a button. So this could be broken. I don't know. Never had luck with this. So we're gonna first of all, it's not even plugged in. Nothing's gonna happen there. Okay, we're gonna plug it in. I'm gonna turn off the set here. Okay, it's off. And we're gonna apply power. We're gonna go still through the dim bulbs because I'm a chicken. What do we see? Nothing. What if I push that button? Nothing. That's high side. Low side. Pushing the button. Not pushing the button. Pushing the button. There's nothing going on there at all. I'm just thinking, is there anything else I can poke at safely in here? Well, maybe there's nothing leaking. We have 120 volts ready to go. Let's turn the set on and we'll repeat this. Oh, we're getting something now. Push the button, I get something different. High side. We reverse the plug. Low side gives a high, and the high side gives a low. Reverse the plug. High side gives a low. High side gives a high now. Low side gives a little low. So you add this reading and this reading, you get the reading I had a moment ago. The meter would go right off a little bit. That's kind of curious too. Okay, so what are we finding out here? Don't really know. Leakage. The meter's going right up. So, and what is that measured in? Is it measured in anything? Can we see it here? Microamps of leakage. So this is the top scale here is 800 microamps. So that's close to a milliamp. Wouldn't it be 800? Hey, radio, what are you doing? loose tube again. I just happen to pick the right one. Yes, I did. Okay, so what's going on here? Loose connection on the grid. The tube itself is loose. There, we'll give it the brutal treatment. When I'm wiggling the tube like that, I'm wiggling the pins, you know, like that, kind of grinding the pins into the socket a bit. That sounds totally different. Not receiving anything. What happened? What antenna am I switched to, Jimbo? Okay, there we go. Sort everything out. Okay. We're going to nip that capacitor and see what happens. Just a little nervous. Okay, so I think I'm just too chicken. Okay, I'm going to cut it. I'm cutting it off the ground connection. Should probably cut it off the other end. Okay. I'm sure I could have done that live. I'm just such a chicken. Well, that gives you an idea what's going to happen. Leakage test. The leakage is gone. The leakage must have been through this capacitor. Okay, we got a notion of what that did. Turned this thing into an ugly oscillator. Now we're going to find out. This is a 0.1. It's not. Yeah, no, 0.2. We're going to find out what is up with this. Okay, let's head over to the capacitor checker here. Today's another warm day here, but the majority of the heat I think is past. And tomorrow they're promising a cool day, and then it looks like it's cool all the way. Okay, so first we're going to hit this with 50 volts, and we're watching the eye, a great big capacitor. She's opening. It's opening right up. Huh. Okay, and what's this guy? This is probably a 400? It's a 600. Okay. 150. What do you say about that, Mr. Capacitor? See, you can't do it, can you? Oh, wait. It's just getting to the point where it might open a tiny sliver. So, not much different than the other capacitors. Okay, point two. I will find one. I'll stick it in the radio there and find out if this really affects its operation. I mean, well, I think we obviously know it affects its operation. What would a better capacitor do in there, especially with the leakage test? Okay, so I'm going through some vintage or older capacitors I have. These are all new old stock capacitors. I found one, 0.25 and 200 volts DC. This is probably good. So why don't we give this one a test and see what's up with it. Let's test it with this guy first. So I find if these capacitors are leaky, these tests are bogus. They'll read more capacitance than is really there. So it should be 250, it's 276 on here, a V-loss and an ESR of 0.67, V-loss 0.2. Now I did test the old capacitor doing with this device. I'll do it again because we're trying to have fun here and this is the way to do it. Okay, so less than an ohm and 0.2%. So we have a similar capacitance. Is supposed to be 200 and it's reading 284. It suggests a leak. V-loss 1.5 and ESR. I'm not sure the ESR is important. I'm not sure how to determine what V-loss is either in this instrument. So, but doesn't seem to be as good as the other capacitor. But I think the real test is putting it on the capacitor checker over here. It's whoop, come down. Okay. New old stock. I don't know how old this is. Probably from the mid-90s. That's probably what it's from. Okay, so we're on the 50 volt. What's it do? Here we go. Right open. 150 volt. Right open. 250 volts. Right open. So see, this is an excellent capacitor. It has no leak. Hey, should we hit it? 350? Give it the works. Right open. Beautiful. So there's no leak in this capacitor. It is like new. It tests like a brand new capacitor. Good. Okay, I'm going to put that in. It's a little bit bigger than the original one, but I don't think that's going to matter. And all these guys will have to wait their turn for another radio. Look at all these guys. Some of these capacitors in the container here, their rating is 1,000 volts or 2,000 volts. Yeah, so these were gifted to me by someone who was basically unloading their dead husband's shop. There's a dead man's capacitors here. Oh, that's a real sad way of looking at it. Okay, so I'm going to put that capacitor in, and we will see how well the radio works after that. Okay, I think we're ready here. Let's just turn it off and apply the power. And we'll try the meter reading here. Shouldn't show anything. Didn't last time until I turn the switch on. We're at 119 volts, but going through the dim bulb, so it's going to be significantly less than 120 volts. Okay, back to here. Here we go. How's the radio work? Okay, no boom. That's good. I couldn't possibly make a mistake doing that capacitor, could I? Oh, I could. Okay, let's give it a chance to warm up, and we'll just do the listening comparison here. Sound's going to be tipped on its side now. At least it's not upside down. Hey, what about this? What about this? So we still see leakage there. Low side. Would appear to be exactly the same as it was. Reverse the plug. This is going into an isolation transformer. So in fact it's a transformer in a transformer. It's two isolation transformers we're working here. Lots there, and then if we look at the other side, there'll be nothing there. That must be a hint in itself as to where the leak is occurring. There goes that static again. Is it this tube? Seems to be. So it could be an expansion thing going on, although the tube is barely warmed up. Could be something happening inside the vacuum tube itself, but it seems to respond to simple mechanical shocks there. That would suggest it's just pin contact. Oh, it seems pretty stable now. I don't know. Maybe it's more than one thing. Where's the station? Now, could this have disturbed the alignment somehow? Just checking to see if the volume's going up and down. Doesn't seem to be. Well, that capacitor surely didn't affect the IF tuning. Could it have affected the antenna? It's too much screwdriver. Not much. Very hard to pick these stations out among the noise here. But I know from experience this will work quite well out of my shop. Let's see if we can get that French station. So what I'm going to do is I'm going to hook up that big loop antenna and let this and see and tune in the stronger station, the one I'm usually listening to. It's definitely on loop. Okay, let's bring it up here. Big dig out there. Okay, and we need the connector. Okay, loop antenna. One. Now I think this is really intended for a long wire antenna connection, not a loop. The loop is not what it's expecting. But that's what I'm going to do. So we're going to go on the chassis and on the wire. Nothing too exciting yet. I need to spring release this cable here. Okay, we are connected. Okay, I'll leave it right here. I'll tune the antenna to match. Uh-oh. Something not right. Something's not right. So I've connected to the chassis. Oh, did I flip the switch? I did not flip the switch. That switch is more trouble than it's worth. I wonder how many people get a radio like this and leave the switch in the wrong position the whole time they have it. Okay, back to trying to get some obvious signal out of here. So the antenna does have a response curve, but I can get a few kilohertz this way and that way. There we are. That's not bad, eh? This is probably how it would work out of my shop. What we're going to do is we're going to go down to the strong station and really give it a blast here. Even with the radio's antennas far from being tuned. Not much volume required. Okay, let's peak this antenna up.
We can do this now, and I don't know if they necessarily could before, right? Which is when, and it's funny, like we should talk about this and we start with what is a strike zone. And I don't want to get too granular here, but like that by itself is a really tricky question because I think that a lot of fans, I think rightfully think of the strike zone as like a box, right? It's a 3D box. And so if the ball crosses the plate within that box, from the front of the plate to the very back of the plate, it's a strike. But I will tell you right now,
there we go.
Actually did that with a
99 volts.
I think fans and players would hate it, right?
We didn't even give it the full voltage there. for the test, but that's good enough. Radio's working fine. So what I will do, asbestos has come free here. Asbestos. I was taking the radio out of the chassis, I guess. I don't want to do that. I don't want to rough up the asbestos. Okay, so I got to fix the tear in the speaker here and put it back in its cabinet, but I'm not going to put any of that on video. I'm done with the radio video-wise, I think, until I get around to doing the cabinet along with a couple other radio cabinets. I have three small radio cabinets now that just require some TLC. Maybe I'll do I don't know what I'll do. I don't know what I'll do. Probably end up doing what my wife tells me to do. That's probably what will really happen. So, thanks a lot for watching this series. And you saw the next radio. It's going to be on my bench tomorrow. Thanks a lot, and see you.